In this presentation, a midcarpal fusion will be performed using the variable angle locking intercarpal fusion system. The objectives are to identify the clinical indications, pre-operative planning, to introduce the principles of the variable angle locking intercarpal fusion system, to show the patient position and approach, how to perform a midcarpal fusion, and understand the post-operative treatment. The indications for a midcarpal fusion are post-traumatic midcarpal arthritis following long-lasting scaphoid non-union, SNAC wrist, scaphoid non-union advanced collapse, and scapholunate ligament rupture, SLAC wrist, scaphoid lunate advanced collapse, or midcarpal instability, final stage, midcarpal osteoarthritis. Complete preoperative radiographic and CT scan assessment should confirm the presence of sufficient bone stock for the four-corner fusion procedure, as well as the integrity of the joint surfaces between the radius and the lunate. The extent of the lunate deformity, dizzy, dorsal intercalated segment instability must be determined. The circular plate has a low profile. It has a smooth surface and rounded edges to minimize soft tissue irritation. The variable angle locking plate holes have a cloverleaf design with 4 columns of threads in each hole. There are K-wire holes for temporary fixation. The center plate hole facilitates bone graft application. The variable angle locking technology allows stable fixation with up to 15-degree angulation in all directions to adapt to the specific anatomy. The variable angle locking holes accept 2.4 mm variable angle locking screws or 2.4 mm Cortex screws. There is a 15 mm diameter plate with 6 screw holes and a 17 mm diameter plate with 7 screw holes. In this presentation, a 17 mm plate will be used. The plates and screws are available in stainless steel or titanium alloy. The reamer comes in 2 diameters, 15 mm and 17 mm, to countersink the bones for the plate. The reaming guide and reduction reaming guide are available in 2 sizes, 15 mm and 17 mm, for preliminary fixation of the carpus, optimal guidance of the reamer, and soft tissue protection during the reaming procedure. The reaming guide must be placed so the handle is oriented to the long axis of the radius, whereas the handle of the reduction reaming guide must be oriented perpendicular to the long axis of the radius. Place the patient in a supine position with the forearm positioned on a hand table in full pronation. The use of tourniquet and magnifying loops is recommended. A standard dorsal longitudinal approach to the wrist is used. Make a longitudinal incision over the wrist. Identify and preserve the dorsal superficial branch of the radial nerve, which runs in the radial skin flap of the wound. Incise the extensor retinaculum over the extensor pollicis longus tendon, EPL, opening the distal part of the third extensor compartment or the entire compartment when operating on the foam model. The EPL tendon is then retracted radially together with the tendons of the second extensor compartment. Incise the fourth extensor compartment and retract radially. The EPL is retracted radially and the fourth compartment is peeled off the radius and retracted ulnally. In this exercise, incise the dorsal wrist capsule longitudinally in the midline and retract the flaps to both sides. Next, the scaphoid must be excised. A K-wire inserted into the scaphoid and used as a joystick aids in the removal. Use a scalpel to completely separate the scaphoid and remove it. In the clinical situation, if necessary, use a 1.25mm K-wire as a joystick. With a K-wire, temporarily fix the lunate in neutral position from distal through the capitate. Remove the joystick K-wire. The capitolunate angle can be set to influence how much extension-flexion is possible afterwards. To provisionally fix the carpal bones, first insert a K-wire through the triquetrum and into the lunate to unite these two bones. Insert a second K-wire into the capitate. At this point, complete debridement of the midcarpal joint is mandatory. Preparation of the joint surfaces between the capitate hamate and the lunate triquetrum is optional or may be carried out after provisional fixation. Use a small rongeur and/or chisel to remove the residual cartilage of the joints to be fused. Make sure that sclerotic and dense subchondral bone is removed down to cancellous bone. The capitate is placed on the lunate. Insert the K-wire further to temporarily fix the lunate in the neutral position. In the clinical situation, the use of toothed reduction forceps may produce articular cartilage damage on the main articulating area of the fusion mass. In the surgical procedure, it is mandatory to verify the correct alignment of the carpal bones under image intensifier control. Insert a blunt Hohmann retractor to allow sufficient space for the reduction reamer guide. The instruments needed to ream the plate recess are the reduction reaming guide, 17mm. Use the reduction reaming guide if distraction and compression of the carpal bones is required. 4 or 5 K-wires, 1.6mm with trocar tip, and the reamer, 17mm. Apply the reduction reaming guide slightly open and center it over the forebone junction. The amount you open is determined according to preference. The reduction reaming guide should be applied perpendicular to the long axis of the radius. The guide has 2 palmar prominences that sit on the lunate and triquetrum. In this way, the final guide position is horizontal. It is important that the reduction reaming guide be applied from radial for the right wrist and from ulnar for the left wrist. Fix the guide with at least 1 K-wire per carpal bone. Place the first short K-wire into the lunate. Place the second K-wire into the capitate. Place the third K-wire into the triquetrum. And place the fourth K-wire into the hamate. To increase the stability of the construct, a second K-wire placed into the lunate or any of the carpal bones may be required. If necessary, remove the lunocapitate K-wire to avoid later interference with the reamer. Open the guide to allow cartilage and subchondral bone debridement using a rongeur and/or a chisel. Make sure the subchondral bone is removed down to cancellous bone. If necessary, cancellous bone grafts from the excised scaphoid or the radial styloid can be inserted into the midcarpal joint before applying the final compression. Ream through the guide to the first laser marking line. The first line on the reamer indicates a reaming depth of 6mm. The subsequent lines are at increments of 2mm reaming depth. Check for sufficient reaming depth by trial placement of the plate. Ensure that the plate edge does not project beyond the bone at any point. If necessary, continue reaming. The plate may be provisionally fixed with a K-wire to secure it in position. The instruments needed to insert variable angle locking screws are the Combi Drill Guide 1.8 for variable angle locking screws and standard Cortex screws, the drill bit 1.8 mm with marking, the depth gauge for screws 2.0 to 2.7 mm, the self-holding T8 star drive screwdriver shaft, the handle with quick coupling, the torque limiter 0.8 Nm, and the handle for torque limiters. Place the first variable angle locking screw into the lunate. Insert the variable angle end of the Combi drill guide fully into the plate hole. Drill the hole with the 1.8 mm drill bit at the desired angle. It is important not to angulate more than 15 degrees from the central axis of the screw hole. Overangulation could result in difficulty in getting the screw to lock. Measure the screw length using the depth gauge. Insert the variable angle locking screw using the T8 star drive screwdriver shaft attached to the handle with quick coupling. Do not fully tighten the screw. The second variable angle screw is placed into the capitate using the same technique. The next variable angle screw is placed into the hamate. The fourth variable angle screw is placed into the triquetrum. It is recommended to place a second variable angle screw into the lunate. An additional screw can also be placed into the hamate and the capitate to increase the final stability of the construct. The K-wire crossing the triquetrum and lunate is now removed. Remove all the K-wires holding the reduction reaming guide in place and remove the guide. Use the 0.8 Nm torque limiter to perform the final locking of the screws. The torque limiter prevents over-tightening and ensures that the screws are securely locked into the plate. The result is a solid midcarpal fusion. After surgery, it is recommended that the patient wear a support wrist splint for 2 weeks. A removable splint should be used until bone healing is confirmed by X-ray control. During this period, active and assisted wrist motion should be performed. Passive wrist motion is not recommended until the 8th postoperative week. Midcarpal fusion provides, in most cases, a functional wrist motion. The X-rays at 3 years postoperative show correct plate and screw positioning. 2 screws are inserted into the lunate. All the screws reach the subchondral bone. The plate is flush to the dorsal carpal rim, and the carpal height and alignment have been restored, allowing functional wrist motion. This presentation has shown the clinical indications, pre-operative planning, the principles of the variable angle locking intercarpal fusion system, the patient position and approach, how to perform a midcarpal fusion, and to understand the post-operative treatment.